Hi guys, good day. It's me, Teacher MJ. Our topic for today class, it's all about simplifying radicals. So without further ado, let's do this topic. So before answering this one class, we need to know the basic examples in simplifying radicals. Alright, let's start the basic example class. What if you have the square root of x squared? What would be your answer class? So the square root of x squared, that would be x, right? Now why is that, sir? Because if the index and the exponents are the same, you can just simply cancel this out. Once again, class, in every square root, the index is 2. So we can just simply cancel this out and then copy x. Okay? Just remember, class, writing this radical into exponential form. We can also write this one as x. Then this exponent 2 will be the numerator of the fractional exponent. And this index 2 will be the denominator. So that would be x raised to the power of 2 over 2. That would be x raised to the power of 1 or equivalent to x. Right? So our answer is x. Rule number 1, class, in the laws of radical, if the index and the exponents are the same, you can just simply cancel this out and then copy the number or the equation inside the radical symbol. That's the rule there. Rule number 1. So you can see the video, class, for the laws of radical. Feel free to see the link on the description down below with regards to the laws of radical. Alright, so let's try another example, class. What if the index and the exponents are not the same? What if we have the square root of x raised to the power of 4? So what would be your answer, class? Of course, the index here is 2, right? So the index and the exponents are not the same. So the thing that you will do, class, you think it this way. Is 4 divisible by 2? Can we divide 4 by 2? Because if we can divide 4 by 2, we can just simply answer it right away, class. Just simply divide this exponent by the index. 4 divided by 2, that would be 2. So our answer will be x squared. Very easy, class. Just divide 4 by 2. Copy x, then 4 divided by 2, that is 2. So copy x, then 4 divided by 2, that is 2. So that would be x squared. That's your answer, class. Because if you write this one in exponential form, this will be equivalent to x, copy x. This exponent 4 will be the numerator of the fractional exponent, and this 2 will be the denominator. And 4 divided by 2, we have x squared. Easy, right? So the thing that you will do, class, if the index and the exponents are not the same, so you think it this way, is the exponent, can we divide the exponent by the index? Because if we can divide, just simply divide, class. 4 divided by 2, that is 2. Copy x, x squared. Easy, right? So let's try another example. What if we cannot divide? Let's try another example, class. What if we cannot divide? What if we have x raised to the power of 9? So can we divide 9 by 2? Can we divide 9 by 2? Nope, we cannot divide 9 by 2. 9 divided by 2, you get a decimal answer. So the thing that you will do, class, is you need to factor this out. Factor this out, class. So this will be x raised to the power of 8 times x, right? Because x raised to the power of 8 times x, that would be x raised to the power of 9. Understood that there's one here in the laws of exponents, class. If they have the same base, simply copy x, then you will add the exponent. That would be 8 plus 1. And 8 plus 1, that is 9. X raised to the power of 9. So we have x raised to the power of 8 plus 1, that would be x raised to the power of 9. So now, can we divide 8 by 2? Yep, we can divide 8 by 2. Okay, 8 divided by 2, that is 4. So once again, we can also write this one as x raised to the power of 8 times x raised to the power of square root of x raised to the power of 1. Once again, we can also write this one as the square root of x raised to the power of 8 times the square root of x raised to the power of 1. So we can erase 1. Understood that there's 1 here. So can we divide 8 by 2? There's 2 here. Can we divide 8 by 2? Yep. We can divide 8 by 2. 8 divided by 2, that is 4. So that would be x raised to the power of 4. Can we divide 1 by 2? Nope, we cannot divide. So simply copy square root of x. So this will be our answer, class. Okay, so that's our answer there. So once again, now you'll be asking questions. Sir, why is it 8? We can use 6, sir. We can use 6. We can use 4. That's correct. We can use 6. We can use 4. But we need to have the greatest divisible number, class. Okay, the greatest divisible number. So that's why we have 8. Okay, 8 and 1. The greatest divisible answer. Let's try another example, class, with regards to the numbers before answering this one. What if we have the square root of 16? So do we have the square root of 16? Yep, the square root of 16, that is 4, because 4 times 4, that is 16. Once again, these are the perfect squares. Just remember, class, the perfect squares. We have 4, 9, 16, 25, 36, 49, 64, and so on, right? Because if we get the square root of these particular numbers, you will get a whole number answer. Example, class, the square root of 4, that is 2. The square root of 9, that is 3. The square root of 16, that is 4. The square root of 25, that is 5. Square root of 36, that is 6. The square root of 49, that is 7. Square root of 64, that is 8, and so on. So if we get the square root of these particular numbers, you get a whole number answer. So once again, the square root of 16, that is 4. Now, what if, class, the number is not a perfect square? What if we have the square root of 18? Is 18 a perfect square? Do we have 18 here in the perfect squares? Nope, we don't have. So the thing that you will do, class, is you find two numbers that one number is a perfect square, the other is not, that when you multiply the two numbers, you will get 18. Okay, once again, you find two numbers or you find factors of 18 that when you multiply the two numbers, you will get 18. One number is a perfect square, the other is not. So the thing that you will do, class, you check in this perfect squares that we can divide it by 18. Yep, 9, we can divide 9 by 18, right? 18 divided by 9, that is 2. And 9 is a perfect square, so therefore, we can write this one as the square root of 9 times the square root of 2. Alright, so once again, you find two numbers that one number is a perfect square, the other is not. 9 is a perfect square, 2 is not. So the square root of 9, that is 3, and the square root of 2, there is none, so simply copy square root of 2. So square root of 9, that is 3, times the square root of 2, there is none, so 3 times square root of 2, that would be 3 square root of 2. And that would be your final answer, class. I hope you get this one, class. For not a perfect, if the number is not a perfect square, you will find two numbers that one number is a perfect square, the other is not. But do not be worried, class, we will be having examples for this one, numbers 4 and 5. So we will try that one. Let's answer first numbers 1 and 2. Alright, so let's answer simplifying radicals. Number 1, square root of x raised to the power of 5. Can we divide 5? Okay, the exponent here, 5, by the index 2. Understood that there's 2 here. Can we divide 5 by 2? Nope, we cannot divide, because if we can divide, we can get the answer right away. But since we cannot divide, we need to factor this out. So we can factor this out by x raised to the power of 4 times x, right? So we need to have the highest divisible exponent, and 4 is the highest divisible exponent. Okay, we have 4 and 1. 4 plus 1, that is 5. So can we divide now 4 by 2? Yep, we can divide 4 by 2. We can actually make this one, class, individually. We can write this one as the square root of x raised to the power of 4 times the square root of x. Okay, so this will be the square root of x raised to the power of 4. We can divide 4 by 2. Understood that there's 2 here. So we can divide 4 by 2. 4 divided by 2, that is 2. So cancel this out, the radical symbol, copy x squared. So 4 divided by 2, that is 2. So you have x squared. Then can we divide? There's 1 here. 1 by 2. Nope, we cannot divide. So simply copy, class. Square root of x. We can remove index. Understood that there's 2 here. So this will be our answer, class. Okay? X squared, square root of x. Or you can have this answer, class. To make it simple, class, square root of x raised to the power of 5. You can have this answer. Square root of x raised to the power of 4 times x. So the square root of x raised to the power of 4, we can divide 4 by 2. 4 divided by 2, that would be 2. You put it outside the radical symbol, so that would be x squared. And understood that there's 1 here, we cannot divide 1 by 2. So simply copy square root of x. X will be still on the inside the radical symbol. So 4 divided by 2, that is 2. So put it outside, since we can divide 4 by 2. That would be x squared. Now, we cannot divide 1 by 2. Simply copy square root of x. So this will be your answer, class, for number 1. Alright, so the answer for number 1, that would be x squared, square root of x. I hope you get this one, class, but if not, do not be worried. We will have more example, class. If we can make it 10 example, that would be better for us. So let's try many examples. Alright, let's try number 2. So we have the cube root of b raised to the power of 7. So the cube root of b raised to the power of 7. So we can write this one as the cube. We cannot divide 7 by 3, right? 7 divided by 3. That's cannot be. So we need to factor this out. So this will be the cube root of, what will be the greatest number, class, that is divisible by 3? That near to 7. That's correct. That would be 6, right? Before 7, that is 6. Can we divide 6 by 3? Yep, we can divide 6 by 3. So that would be b raised to the power of 6 times b. Because understood that there's 1 here, and 6 plus 1, that is 7. So b raised to the power of 6 times b. So can we divide 6 by 3? Yep, 6 divided by 3, that is 2. So we put it outside the radical symbol. That would be b squared. Once again, 6 divided by 3, that is 2. So that's why we have b squared. Then, can we divide 1? Understood that there's 1 here, 1 by 3. Nope, we cannot divide. So copy cube root of b. So the answer is b squared cube root of b. That's the answer, class. Once again, if you do it individually, this will be the answer. Because there are some students that they will be confused with this one. So you can write this one as the cube root of b raised to the power of 6 times the cube root of b raised to the power of 1. And in this scenario, we can write this one in exponential form. This will be b, then 6 will be the exponent. 6 will be the numerator of the fractional exponent. And 3 will be the denominator times, so this will be the cube root of, since we cannot divide 1 by 3, copy, cube root of b raised to the power of 1. So 6 divided by 3, that is 2. So that's why we have b squared times the cube root of b raised to the power of 1. Copy the cube root of b raised to the power of 1. Or this will be your answer, class. So it will take time, class, if you do it that way. So it's very simple, class. Just divide, class. 6 divided by 3, that is 2. B squared. Then copy the cube root of b raised to the power of 1. So you still have b raised to the power of 1. Alright, so that's the answer for number 2. Let's try number 3. So the answer for number 2, that would be b squared cube root of b. Alright, let's try number 3. So square root of 25x raised to the power of 6, y raised to the power of 7. Alright, so do we have the square root of 25? Yep, we have the square root of 25. Square root of 25, that is 5. That's correct. 25 is a perfect square. How about this one, class? 6. Can we divide 6 by 2? Understood that the index here is 2. Can we divide 6 by 2? Yep, we can divide 6 by 2. How about for 7? Can we divide 7 by 2? Nope, we cannot divide 7 by 2. 7 divided by 2, we cannot divide that one. So therefore, we can still simplify this one. You need to factor this out, class, before simplifying. So copy first 25. Since we can divide 6 by 2, simply copy x raised to the power of 6. And for y, that would be y raised to the power of 6 times y, right? Therefore, your final answer will be square root of 25, that is 5. You put it outside the radical symbol. So once again, class, square root of 25, that is 5. Put it outside the radical symbol. And how about this one? 6 divided by 2. We can divide 6 by 2. 6 divided by 2, that is 3. So we have x cubed. Put it outside the radical symbol. For y, so once again, find the highest exponent, class, that is divisible by 2. Highest exponent that is divisible by 2, that is 6. Because this is 7, so 6 plus 1, that is 7. So 6 divided by 2, that is 3. So y cubed. Then since we cannot divide 1 by 2, so therefore this y will remain inside the radical symbol. So that would be square root of y raised to the power of 1, or simply y. So this will be our answer, class, for number 3. Alright, so that would be the answer for number 3, class. So let me just write the answer here. This will be 5x cubed y cubed square root of y. I hope you get this one, class. Once again, if you have some questions, class, feel free to leave a comment in the comment section down below, because we will be answering that one. Alright, let's try number 3. So what if we have the square root of, okay, let's try number 3. Square root of 50, x raised to the power of 9, y raised to the power of 6. Alright, so is 50 a perfect square? Nope. 50 is not a perfect square. So we find two numbers, that one number is a perfect square, the other is not. That when you multiply, you will get 50. Of course, 50, we can simplify this one with 25, right? 25 times 2, that is 50. 50 is not a perfect square, so we find two numbers. So one number is a perfect square, the other is not. So for 50, we can simplify this one with 25 times 2. For x raised to the power of 9, can we divide 9 by 2? Understood that there's 2 here. Can we divide 9 by 2? Nope, we cannot divide. So we can write this one as x raised to the power of 8 times x raised to the power of 1. Okay, 8 plus 1, that is 9. How about for 6? Can we divide 6 by 2? Yup, we can divide 6 by 2. So we copy y raised to the power of 6, since we can divide it directly. Alright, so our final answer will be, do we have the square root of 25? Yup, the square root of 25, that is 5. Put it outside the radical symbol. Alright, how about 2? Do we have the square root of 2? Nope. 2 is not a perfect square, so therefore 2 will remain inside the radical symbol. How about this one? X raised to the power of 8. Can we divide 8 by 2? Yup, we can divide 8 by 2. So 8 divided by 2, that is 4. So you put it outside the radical symbol. Put this x outside the radical symbol. And then 8 divided by 2, that is 4. So that would be x raised to the power of 4. How about this one? X raised to the power of 1. Can we divide 1 by 2? Nope, we cannot divide. So this x raised to the power of 1 will remain inside the radical symbol. And then this y raised to the power of 6. Can we divide 6 by 2? Yup, we can divide 6 by 2. 6 divided by 2, that is 3. So you put it outside the radical symbol. That would be y cubed. Then the square root of 2 will be still, 2 will remain inside the radical symbol. So copy 2. Then x raised to the power of 1 will remain inside the radical symbol. So 2x raised to the power of 1, or just simply copy 2x. Alright, so this will be our answer class for number 4. So 5x raised to the power of 4, y raised to the power of 3, square root of 2x. Alright, that's the answer class for number 4. Now you try this one class, number 5, and then we will have another example. So you try this one, number 5, and let's try another example class. So try this one, number 5 class, and you put your answer on the comment section down below. So the square root of 27, x raised to the power of 5, y raised to the power of 7. You try this one class. Alright, let's try another example. What if we have the cube root? Okay, let's try another example class. So you paused the video a while ago, you try number 5 class. You put your answer in the comment section down below. Let me check class if you really understand our topic class in simplifying radicals. Alright, example number 6. So we have the cube root of 16, x raised to the power of 14, y raised to the power of 15, then z raised to the power of 20, or 20. Alright, so is 16 a perfect cube? Nope, 16 is not a perfect cube. What are those perfect cube class? So the perfect cube, we have 2 raised to the power of 3. So 2 times 2 times 2. So 2 times 2 times 2, that is 8. And we have 3 raised to the power of 3. 3 times 3 times 3, that is 27. So therefore, 27 is a perfect cube. 8 is a perfect cube. 4 raised to the power of 3, that will be 4 times 4 times 4. That is 64, and so on, right? 5 raised to the power of 3, 5 times 5 times 5, that is 125. So these are perfect cube, and so on. So, okay, and so on. So these numbers are perfect cube, and 16 is not here, right? 16 is not a perfect cube. So the thing that you will do, class, you find two numbers that one number is a perfect cube, the other is not. That when you multiply the two numbers, you will get 16. Of course, we can simplify cube root of 16. This 16 class, we can simplify this one as the cube root of 8 times 2, right? Is 8 a perfect cube? Yup, 8 is a perfect cube. And 8 times 2, that is 16. So that's the thing there, class. If the number inside the radical symbol is not a perfect cube, You find two numbers that when you multiply the two numbers, one is a perfect cube, the other is not. So therefore, in this scenario, we can simplify this one as the cube root of 8 times 2. And 8 is a perfect cube. The cube root of 8, that is 2. Because 2 times 2 times 2, that is 8. So 8 times 2, the cube root of 8 times 2. For x raised to the power of 14, class. So since this is 3, the index is 3, we can simplify this one. We can factor this out by x raised to the power of 12 times x squared. Okay, now you'll be asking questions, sir, why is it 12? Because we need to get the highest exponent that is divisible by 3. And the highest exponent that is divisible by 3, going to 14, that would be 12, right? 12 plus 2, that is 14. Okay, 12 plus 2, that is 14. 14, we cannot divide it by 3. Next number, near to 14, that would be 12. 12 plus 2, that is 14. 12 plus 2, that is 14. Now for y, 15. Can we divide 15 by 3? Yep, we can divide 15 by 3. So simply copy y raised to the power of 15. How about for z, class? 20 divided by 3. Can we divide 20 by 3? Nope, we cannot divide. What would be the number, class, that is near to 20, that we can divide it by 3? That's correct. That would be 18, right? So z raised to the power of 18 times z raised to the power of 2. 18 plus 2, that is 20. Alright, and then, so this will be the cube root of 8. So that is 2. Once again, the cube root of 8 plus, that is 2. Because we can write this one as the cube root of 2 raised to the power of 3. 2 times 2 times 2, that is 8. So the cube root of 8, that is 2. So the cube root of 8, that is 2. Put it outside the radical symbol. Do we have the cube root of 2? Nope. 2 is not a perfect cube. So therefore, 2 will remain inside the radical symbol. How about this one, class? X raised to the power of 12. Can we divide 12 by 3? Yep, we can divide 12 by 3. 12 divided by 3, that is 4. So put it outside the radical symbol. That would be x raised to the power of 4. 12 divided by 3, that is 4. How about for x squared? Can we divide 2 by 3? Nope, we cannot divide 2 by 3. So x squared will remain inside the radical symbol. For y raised to the power of 15, can we divide 15 by 3? Yep, we can divide 15 by 3. 15 divided by 3, that is 5. So that would be y raised to the power of 5. Put it outside the radical symbol. For z raised to the power of 18, can we divide 18 by 3? Yep, we can divide 18 by 3. That is 6. Put it outside the radical symbol. Z raised to the power of 6. And for z squared, we cannot divide 2 by 3. So therefore, z squared will remain inside the radical symbol. And the final answer on the last part, that would be the cube root of 2. We still have 2. Okay, and we have x squared. And we have z raised to the power of 2. That's it, class. This will be the answer for number 6. Alright, quite complicated, right? So we need to do it step by step. Alright, so let's try another example, class. Example number 7. The square root of 50 over 2. X raised to the power of 7. Y raised to the power of 10. Z raised to the power of 6 over x cubed, y raised to the power of 4, z raised to the power of 2. Alright, so in this scenario, class, check first if we can divide the number. Can we divide 50 by 2? Yep, we can divide 50 by 2. 50 divided by 2, that is 25. So we have the square root of 25. So 50 divided by 2, that is 25. Now in this scenario, class, x raised to the power of 7 over x cubed, if they have the same base, we can copy the base, then subtract the exponent, class. This, remember, class, in the laws of exponents, the quotient rule, same base, copy the base, then subtract the exponent. So that would be x raised to the power of 7 minus 3. And for y raised to the power of 10 minus 4. And for z raised to the power of 6 minus 2. So this will be square root of 25, x raised to the power of 7 minus 3, that is 4, y raised to the power of 10 minus 4, that is 6, z raised to the power of 6 minus 2, that is z raised to the power of 4. Alright, and our final answer will be, what would be the square root of 25, class? Square root of 25, that is 5. You put it outside the radical symbol. So 5. Can we divide 4 by 2? Understood that there's 2 here. So can we divide 4 by 2? Yep, we can divide 4 by 2. 4 divided by 2, that is 2. So you put it outside the radical symbol, that would be x squared. For y, raised to the power of 6, can we divide 6 by 2? Yep, we can divide 6 by 2. 6 divided by 2, that is 3. So y cubed. And for z, raised to the power of 4, can we divide 4 by 2? Yep, 4 divided by 2, that is 2. So z raised to the power of 2. And that would be your final answer, class, for this example number 7. Alright, let's try another example, class. Last example, class. Alright, last example. You pause the video. I will be erasing this one. Example number 8. Last example. So once again, class, if you have some questions with regards to radicals, you can always message me in our Facebook channel. Same name with our YouTube channel. Or you can put a comment in our YouTube channel, class. I will be answering that one. Alright, example number 8. Do not forget, class, to answer example number 5 a while ago. Example number 8. What if we have the cube root of 8 over 27? X raised to the power of 7, x squared. Y raised to the power of 5. Y raised to the power of 2. Z raised to the power of 10. And Z. Alright, so in this scenario, class, can we divide 8 by 27? Nope. We cannot divide 8 by 27. So the thing that we will do is we'll just simply copy 8 over 27. So we have the cube root of 8 over 27. Since we cannot divide 8 by 27, we copy, class, 8 over 27. Now for the same base, okay, same x, so simply copy x. Then we will be subtracting the exponent. So 7 minus 2. So 7 minus 2. Now for y, so copy y, then subtract the exponent, 5 minus 2. And for z, so we have z raised to the power of 10. 10 minus 1. So once again, class, same base. Simply copy the base. Then you subtract the exponent, class. I hope you remember, class, the quotient rule on the laws of exponents. Once again, if you want to learn more about the laws of exponents, I will just put the link on the description down below with regards to the laws of exponents. Alright, now in this scenario, class, is 8 a perfect cube? So we have cube root of 8. So is 8 a perfect cube? Yup, 8 is a perfect cube. Okay, so 8 is a perfect cube. And 27, is 27 a perfect cube? Yup, 27 is also a perfect cube. What is the cube root of 27, class? That is correct. That is 3. Because 3 is 3 cubed, that is 27. 3 times 3 times 3, that is 7. And for 8, the cube root of 8, that is 2. Because 2 times 2 times 2, that is 8. Once again, class, the cube root of 8, that is 2. Because 2 times 2 times 2, if you multiply 2 by itself 3 times, you get 8. And for 27, that is 3. Because if you multiply 3 times, that is 27. So the cube root of 27, that is 3. And the cube root of 8, that is 2. So this will be, let me copy first the equation, the cube root of 8 over 27. And this will be x raised to the power of 5. Y raised to the power of 3. And z raised to the power of 9. Now since this is 5, for x, can we divide 5 by 3? Nope, we cannot divide. How about for y? 3 divided by 3, yep. For z, 9 divided by 3, yep, we can divide. So we need to simplify this one first. So this will be the cube root of 8 over 27. And this will be x raised to the power of 3 times x squared, right? 3 plus 2, that is 5. So we can divide 3 by 3. And for y, copy y cubed. For z, z raised to the power of 9. Simply copy, class. Since we can divide 3 by 3, we can divide 9 by 3. For x, we cannot divide 5 by 3. That's why we factored it out by 3 and 2. So our final answer will be, so the cube root of 8, that is 2. So the cube root of 8, that is 2. The cube root of 27, that is 3. Put it on denominator. For this one, x cubed, we can cancel this out because this is the same. 3 divided by 3, that is 1. So 3 divided by 3, that is 1. You put it outside the radical symbol on the top part because this is on the top. So x. And for x squared, we cannot divide 2 by 3. So x squared will remain on the radical symbol, on the top class. Okay, on the top part. For y raised to the power of 3, we can divide 3 by 3. So this is y. Put it outside the radical symbol. Cancel it out. So y raised to the power of 3. We divide 3 divided by 3. That is 1. So y raised to the power of 1, or y. For z raised to the power of 9. 9 divided by 3. That is 3. Put it outside the radical symbol. Z raised to the power of 3. And we still have x squared. So cube root of x squared. And that's it, class. This is our final answer for number 8. Quite complicated, right? But we need to do it step by step. So once again, if you have some questions in simplifying radicals, go ahead, class. You leave a comment in the comment section down below because we will be answering that one. So I hope you learned something new today. If you like this video, do not forget to like, share, and subscribe. You share it to your friends and to your classmates so that we can help more students. Once again, this is Teacher MJ. Have a great day, class. Do not forget to answer number 5, class. Question number 5. You put your answer in the comment section down below. Goodbye for now. Bye-bye.